What's up, peeps? This is Mo from Moga Creative coming to you from the City of Angels with the very first video on design. And we're going to be starting off hopefully a series of videos about design, and we're going to start them off with racing drones. And the first drone we're going to take a look at is the Cat 7, which is a prototype design running 5-inch props. And we're going to do a little build video of this, and then later we're going to hopefully do the design video of it, and how we basically went from idea to flying drone. Maybe later in the channel episodes we'll get into further design, like stuff for technical things, like this is a HoloLens spectator rig mount. That was fun to design and create and is out there now. So anyway, let's get into the episode. We're going to take my tardigrade friend here, who is flying throughout the universe to populate the planet, depending on your point of view. And that's why we're here. So he's here with us too. Okay, let's get started. Might throw in a little commentary about the drone design as we go, even though I should cover that in another video. So frame is supposed to be 6 mils thick. It's actually about 5 something right now. Let me just pop this guy for you guys. This was a gift from my brother. I think he got it from Harbor Freight, which is pretty sweet. 519, so it will be 6 in the end design. This is just the prototype, so you guys are watching me build this out for the first time. There are some issues that I've ran into. So starting off here, we've got, just to give you guys a rundown, we've got 4 12 mil screws. They're aluminum. Oh, there we lost focus. 4 14 mil, and that's for the canopy. And then we have 8 motor mount screws. These are 8 mil, and that's to get through the frame base. This piece here is part of the canopy back. It's also what holds multiple antennas. You can go with a whip, or you can go with your sort of standard, you know, I forget the name of it. Okay, here we go. So these 2 screws here are your camera mount screws. They'll screw into these small holes here. The dampeners, obviously. Now on the frame, because it's supposed to be 6 mil thick, these canopies are actually a little smaller than they're supposed to be, being 5.18. So everything is not fitting together perfectly. It will in the end build, but my manufacturer accidentally sent me the wrong thickness, so we're getting back to that. To look at the canopy real quick, hopefully this gets a little focus. That's a milled carbon fiber plate, and it's spec'd out to fit our components just exactly. So it's super lightweight, it's super strong. This is the flush side that faces out, and then internally this is the CNC side that you know, has a little bit of an extension here to make sure it grabs the micro well, which we'll get into the components in a little bit. Okay, so let's just throw some screws in here and start. I'm going to go into a little bit more detail about these pieces. I've been prototyping a lot of different material types. You can see here I have a different type. I've got the aluminum, and these are threaded for 3M. I've also got, you know, aluminum versions of the brace mount bracket. Those are 3D printed. They do need to be tapped. I can and do tap them, and that actually works really nice. Just a little bit heavier than the plastic. Just to show you guys one of the other designs here real quick, just sort of flash it up here. This is for my 3-inch build. It's super light. Love this design. Right now it's currently in that's its sort of beta form. This is its sort of alpha form right here. And I haven't actually pulled this thing apart because it's so damn fun. This is 3D printed carbon fiber from Marked Forge, which is of a much higher quality than you'll find elsewhere. I won't go into the details of that, but basically this was a full 3D printed carbon fiber top canopy. It only has 4 mount screws on a 30.5 frame, and man, this thing rips. I've got F20s on here. What sort of standard Runcam micro. Anyway, I'll go into this one another time. Back to our main bad boy. So here are our brace mounts. So I'm just going to thread these up real quick, and sometimes it requires me to actually use a hex driver to get that in there, so I'm going to use that. My little table of supplies over here. This is my first video ever, so bear with me here. I try not to be too whatever the word would be. You guys know what I'm talking about. Okay, so that's screwing in there. It's actually biting into this. This print material is actually a rubberized material that has a lot of flex and give, and it's super durable at the same time. And I actually prefer this to the aluminum. One, it's lighter. Two, it absorbs a heck of a lot of impact, and you'll see when I build this up, there's not going to be a lot of negative effects for that. And also, it does some dampening in and of itself. We won't hopefully see wiggle in the camera from that, but that remains to be seen. Okay, let's just get these on here real quick if I can. And this is probably just going to be an unedited full video of me screwing around with this stuff, so you guys will have to forgive me unless I involve some editing magic here, which my After Effects skills are lacking right now. Okay, it's going to blast these on, no particular order. These are symmetrical, they work for any position. And if I ever do sell this design or pieces like it, you can get these made pretty cheaply. I sell them at 8. I basically have them made in little brackets of 8, so that if they were to break, they'd be pretty easy to replace. Which, because of the design, most of the components are pretty easy in and out. Okay, last one coming up. Let's see. So I should have a full other video, and if I can get the link up here, I'll blast it, that will describe how I designed this drone and why the features are the way that they are, and so forth and so on. And that's sort of really the point of what I want to be doing on here. I don't want to be reviewing drones or doing total build videos. What my main purpose is to show you guys how I design drones and maybe go into some of the manufacturing process for people who are interested in designing their own drones. I've found it to be super fun and rewarding, especially when they fly. I'll show you some interesting crash videos too. Okay, so anyway, that is the basic setup there. Those are the 12 mil screws coming up into our rubberized mount forms, and now really would be the time when I'd add sort of the bad boy of the show. So let's just get into it and do it. I'm not going to hesitate. We'll just go through this as quickly as we can. So we're going to be using this beast. I'm not going to go into any detail. There's other people who've done videos on these. This is the Emax F4 Magnum FC. That's 30 amps for our ESCs, 4-in-1 B&L Heli S. It's got the 200 megawatt, or what is it? I don't know if that's, yeah, I don't know milliwatt, what it's going to be. VTX, that's adjustable. The OSD is built in, and you get a FreeSky receiver coming with that. So anyway, we'll just peek that open. Now, I'm a big fan of UAV Futures and Joshua Bardwell, and those are the guys that I watch mostly. Also, Drone Camps RC, Drone Mesh, and a couple other guys in there who I'm missing. Drone Flyer, I think, or Flyer RC, I forget. I'll have to link their stuff, but I love them. And from a lot of their advice, I've sort of, you know, put this drone together by spec. So anyway, this is, no one's actually used this little piece, except for maybe Drone Camps RC, but don't quote me on that. So this thing's a beast, and we're going to throw it in here real quick. I'm going to kind of disassemble it, but the whole point of me talking about some of my YouTube internet heroes is that Joshua Bardwell is a huge, you know, proponent of not using, you know, the same screws, an integrated stack, basically, where you have your mount screws and then your flight controller on there. And basically, the design that I've got is sort of uses that to basically gain the most efficiency, not having to have other holes out here or, you know, wrap stuff around the front. You'll see in the end. So anyway, to combat that, what I've done is picked up the dampeners here. And the dampeners will go in between this flight stack, and it just so works out that this will work out perfectly. These are actually 6mm gaps in here. Those are 4mm little, what am I saying, spacers, I guess they are. So I'm just gonna unbolt this real quick, keep my pieces, and we'll slide the stuff in there. You might notice that my little brace mounts right here, these guys, they're actually going to pinch just a tiny bit on the corners of this, the ESC mounts right here. And because it's rubberized, it doesn't really matter, but they are being redesigned to be a 0.5 millimeter thinner on either side so that that does not occur with this flight board. Anyway, every flight board's different, so it's tough to plan for them all, but basically I loved this one. You know, it's got a, anyway, I won't go into all the details, but you can sort of reason as to why I would use this piece of hardware in such a, you know, lightweight, I guess as clean as possible drone. Hopefully it doesn't burn out on me. Okay, let's get these screws out of here since we won't be using them. And here we go. So I've got my the base here with my power and ESCs on the side. It plugs in, so that's super sweet. Sorry about the focus, guys. Total amateur hour video. Okay, so anyway, that's the back. This piece right here, get that rotated around so you can see that a little better. This little indent here is for our strap to go around and hold our XT60 cord so that we don't have a lot of stress on the board. That's one of the little pieces I designed in there. Okay, so just bringing this in, we're looking at, you know, straight away, so let's just plug that in. You're already seeing, actually, so I've got to rotate these out a little bit to get it in there in the first place, which is why this is a prototype, and the final one will actually have a little bit slightly thinner mounting braces. Okay, so let's put this on our little bling here. Here we go, looking sexy. File is the correct size. Happy about that. Okay, so just about only 12 millimeter screws are going to work here. Nothing else will work. 10's too short, 14's too long, and that's because these guys only have about a depth of about 2 millimeters, I think. And if you have anything longer than that, they stand off too high. So let's just cross our fingers here. Hope that gets down to the deck. And it does, but just barely. I mean, it's not really crimping that at all. It's just kind of there. Okay, here we go. Let's put the other guys on here. And I'll cinch this all up so that that sort of stacks. But basically now you got your, I mean, there's no FC or any chips on here, but it's stacked between basically two pieces of rubber. And these dampeners will isolate the FC on top so that it receives less vibration from our frame via the bottom screws and any frame coming off the canopy from wind buffeting. Okay, let's see. Get this guy on there. And we're looking pretty good to go. So normally I wouldn't have done this at this stage. I would have started soldering, which I'm going to do, but maybe in the later part of the video. I think I'm just going to kind of build this up to show you guys what it looks like, cut from there, and then come back. So I'm just kind of crimping these guys back in. Obviously, you can tell those want to bow out a little bit. Fortunately, they're rubberized, and the final design won't have that much of you know, a lack of space. It'll actually have a little gap there, and these will also maintain their strength. So anyway, here we go. Let's just make sure this thing fits together well. There's the front, there's the back. I put it over to correctly. Forgive my mumbling. Okay, so now we got to pay attention to these pins. Almost messed that up. Pins first. There we go. Happy pins. Happy mount. One looks pretty happy. I'm happy with those tolerances. It's looking pretty clean, I think. And you guys can be the judge of that in the comments. Let's just throw my bling on here. And we'll tighten that up in the end, or maybe we don't even need to right now since we're not going to go fly this. But anyway, you guys, after the build video is done, I'll do a beta flight video, show you how I set up the controller for this, at least in some regard. Most of it's just copying Bardwell. I love his arming sequence, who he got from someone else, admittedly, but he shared it, so credit to him. If you haven't seen that, check that out. If I can link, I'll link there. Let's see, come on, guy. Some of these components are super tight because, as you can see, this 6-in-1 board is no joke. And there's been some complaints about, you know, some of the ESC components here being rubbed by the mounts just because this thing is so tight. But anyway, get on through that. Okay. And, you know, this combo here has so few wires, and that's what's going to help make our stack look really clean, and if we don't fry it, just super easy to work with, and looking forward to that. Okay, so basically we've got our flight controller set up in there. We've got our VTX already there. If I was going to do the build part, which we'll get there with soldering, here is my XM Plus, so that'll fit on these 3 pins right there. It's super nice. I might use wires for that, but we'll see. Okay, so let's pull away some of the... this is staying. Okay, so putting together the canopy. This is a little bit tricky because it's not exactly the right size. It's about, you know, almost 3/4 of a millimeter less thick than it's supposed to be. So I'm using these tiny little black washers, which are about 1 millimeter each, in there to mount the camera in there. So you're going to see me fumble with this for a moment while I get the camera setup ready. Okay, here we go. So tiny Allen wrench. I think this is an M2 screw, or it's an M1.5. It's whatever comes with the Swift Micro. So I'm threading that through the canopy here, and then let's see. It's going to thread also my little plastic washer on top of that. Now, so I'm using the Emax over here. Going to be using the Runcam Micro Swift 2, I think is what it is. And then I've got some pretty good motors over here. Hopefully these are the Rotor Riot HypeTrains, so they should look pretty damn sick on this quad. And I think the power to weight ratio is going to be in a very sweet zone. So let us get on with this. Get this Swift out of here. So sexy. Again, I'm not setting up the wires right now. I'm just sort of putting everything together so you can see what the frame looks like with its components in there. Alright, so that's up, good. This is the easy one because all I got to do is find the screw hole and start screwing. And look at that, it's already together. You know, a note about the direction of the carbon fiber on the arms, that will change in the end. I do like my manufacturer. It's just, I think it's a single person, not a giant company. And you know, where I manufacture and who I choose to do it with is a tricky choice. But we'll get into the global politics of where you get your stuff built in some other episode. Okay, here we go. So now the hard part. You'll see me fumble, probably pop this out 10 times like I did last time. Okay, now point of note, I'm putting the camera in right side up because I'm probably not going to go 90 degrees on the flight, but if you wanted to go 90 degrees on the flight, you would flip the camera upside down so that the connectors here didn't interfere with your FC. You'll see what I'm talking about in a minute. Okay, carefully gonna line those up. Hopefully I found the hole, and I found the hole. Good. That's what everyone said. Okay. Just going to tighten that down a little bit. That's pretty tight. And we have our baseline canopy. That's it. 2 screws to start it off. And that's going to mount right here. And we're going to do it right now. Here we go. So, let's get some stuff out of the way. Make a little room. Okay, so what's going in between, again, is this white piece. I do have this in aluminum, which is epic, but it costs $25 or $30 to make it in aluminum, and if I ever wanted to pass this drone design on for other people to buy, it's just, you know, such a high price point for a little connector, whereas this is less than 10 bucks and way better price point. So anyway, I've designed it for both. We're going to use the lighter and more brittle version. This is designed basically to sit in the canopy and hold it like basically like this 15 mil standoff would, which we're going to use in the front. But instead it sits there and it anchors the canopy together, and it not only anchors it together, but it sort of has these dovetail wings that are designed to sit in between the rails of the CNC canopy, and that prevents it from rotating too much. And then this is also your VTX antenna holder. You can also port your RX wires out through those little ports there, you'll see in a sec. So hang with me while I struggle to get this all together. This is sort of the one tricky part when you're building this thing, to get it all nice and lined up. So let's start by just doing that. Gonna set these 14 mil screws there. Those are 3M or M3. If we go with the aluminum version of this, which I definitely would offer, you know, it has to come to me and be threaded and then send out. It's a little bit more time and a decent amount more money, but it's pretty cool looking. It doesn't offer the properties of reducing some of the crash impact, which I will show you later, but let's get to it actually. Let's just stop screwing around here now that we're set up. I'm sort of going to push from both sides these screws into the carbon fiber frame. Maybe I'll just start with one side, find the hole. Find the hole! There we go. Okay, found one. Let's use the force. Excellent. Okay, so now that they're kind of halfway in, at least it's aligning itself from both ends. So I'm going to start screwing. I know you guys can't see this too well, I'm hiding with my hand, but now I'm just screwing one of the screws in, which is going to bite on the center point, and then that's already got, so it's already bitten. So I can just turn over here, flip this, and we'll go from the other side. I'm just sort of waiting for it to bite. And I can feel that it has. Now, when the frame is the correct size, I mean 6 millimeters thick for the canopy and the arms, this is all going to fit together a little bit better than what you're seeing right now. So bear with me here as this comes together. And I'm pushing it way off center because I'm just rotating all that rubber. Okay, there we go. So let's tighten this other side up again now. And there, it's really starting to bite because I can tell this piece is wanting to move. I'm going to rotate it out the other side there. And that's pretty much good to go. So here's the baseline, and you can see that's pretty damn low pro. Oh wait, a little too low pro. So let's get this other washer in there and we'll see what this looks like. The point of me showing you that was, though, that when you are working on this, if you just unscrew these guys a half turn, basically you got a pop top, and you can get them to work on that. Okay, so last 14 mil screws are going in the front brace arms. So far it's been a total of 8 screws, so that's pretty minimal. I'm hoping you guys like that, ladies and gentlemen. Okay, so now I'm doing the same thing. I got it both lined up. I'm just going to set this centerpiece in there. Actually, before I do that, I'm going to make sure these are threaded into the carbon fiber, which they are. The carbon fiber is cut with just enough tolerance so that you don't have to screw your screws through. You can just sort of, if you line them up right, they'll sort of thread right through nicely. I'm gonna mumble a lot and bongle my speech. Here we go. Okay. So same thing. I'm sort of just pinching from both sides. That's allowing me to capture that the spacer in there, and then I'm just gonna screw into that spacer here. I'm gonna do it on both sides before I tighten it down. There we go. Let's get this guy to bite. Hold that spacer if I need to. And I'll show you the difference here in a second. You can see, let me move this out. So basically, if this was, you can see how that's pulling out to the side a tiny bit. Maybe not, it's very subtle. But anyway, when this is the correct size, the washers won't be in there, and it won't bow out this way. And also in here, you won't have this tiny little like half millimeter gap in between both sides, because this will be that much thicker. Also, these will be thinner down here, so they do not interfere with the board, and they'll still be thick up here at 4 mils, so that all the standoff stuff works. But because these are rubberized, even once I've soldered this up, and you guys will see this in the flight video when I do the maiden for this guy, I'm not at all concerned this is pinching the board. It's not really causing strain or stress. I can in fact crank those down even though it's over tight. You can see it bow out there, so I'm gonna be shaking. Anyway, so just loosen that up a little bit so it's not bowing. That's because the frame is the right size. You guys won't have that problem if you're ever flying this thing, but I've got it because this is the beta. Okay, so that's basically it, and that's your drone. And it's designed basically so that you can fly it at a pretty steep, you know, aggressive angle. That's 90, by the way, or whatever. Whoops, I want to hit the lens. I mean, that's pretty damn steep right there, and that's where you can see that connector interferes with the screen of the digital readout of the VTX. So if you wanted to go full 90, you would flip this thing upside down so that your wires were coming out the bottom, which is actually even closer to where they connect to the FC. But I'm going to be probably flying around maybe 60 degrees, kind of the same direction this line is pointing out. So anyway, it should be fine. I will show you guys later how the VTX cables plug in here, or the antennas. The small slit right there is for whip antenna, and it basically just binds and grabs the whip antenna, and the whip antenna just sort of sticks out like that, just a little bit. So it's pretty sweet. I think I'm going to run this with a whip instead of the sort of standard size antenna, just because of drag rate, and this thing is meant for speed and ripping, so hopefully it does. You know, it's designed basically so that you have minimal area on the frame out here. Like, I mean, you know, that body that protrudes in this dimension here causes a ton of drag, and same with the back end. You're still going to have that battery down there, which is going to be a little bit bigger. Let's see, some, you know, that's some Tattoo 1300. Just super light, but you can kind of get the profile there when this is mounted correctly. When you're full tilt, you know, that's a minimal profile in terms of drag. I know that the frame isn't, you know, that's not aerodynamic at all, but it's at least small. So even though you're not aerodynamic and you're sort of air cooling that frame, you're not going to get a ton of extra drag. And in relation to that, also, the arms themselves are basically the thinnest where the most amount of drag is produced by the prop. So I'm trying to, you know, that's why this thing is going to be 6 millimeters thick, is to basically square this up. Eventually it will chamfer it if we can get that service for not too much cost. And it'll basically almost be like a round arm that's super thick. We'll see how this thing handles crashes, but that's pretty much the gist of this. I know there's 100 things I'm missing. There are the straps here. You can also mount a 20 millimeter flight controller, and since some of them are coming out with 25 amp ESCs, you could do a, which is essentially, where's my other drone? This guy. This one here has got a 20 millimeter flight controller. You can sort of see it stacked in there. And then the stack mounts for this frame are the same as the big one I'm talking about. They are at 30.5, so the standard FC sort of square. Anyway, one of the cool things about this frame is that because it's based on a standard flight controller size, 30.5 by 30.5, you could basically put this canopy on any frame that you want. So you could upgrade any frame that you want. And I do have an old design drone, and it's got sort of the version pre-beta, you know, the same one as a small one. This was actually a drone I made for the Sky Zone virtual reality goggles, and it didn't have this canopy. But basically what you could do is, this is a totally different frame style. This is essentially the same arms, but they're individual arms. They're locked together via plates. They're sandwiched, that style. You know, you basically could isolate your flight controller. But, you know, basically what you do is you take everything off, you leave your flight controller on there, you would use just this canopy, and all of a sudden whatever your old drone was that has the 30 by 0.5 by 30.5 mount holes could become basically a ripping racer by just using this canopy and the frame mount components, not the actual frame. Anyway, sort of cool. Little upgrade for your frame if you have frames lying around that are still great, but you just don't mess with them, but you want to upgrade them. You could throw this canopy on there. So you can see this 3-inch right here is relying on the 30 millimeter 30.5 by 30.5. They have the same mounting ratio. So no matter what the frame size was, you could put this canopy on. This one's not available. That's beta design, blah, blah. But this beast, you know, you could put it on basically any 30.5 millimeter frame. Okay, that's pretty much it for the build video right now. Once I'm going to cut to, or maybe I'll keep going and I'll show you guys how I'm going to solder this up when I'm going to put these beasts on here. Just to preview so you guys can see. These freaking things are sexy. The light's not picking up the fact that these windings are done in silver, but looking forward to the efficiency on these. They mount perfectly on this beast. I've actually set up the holes there 16 to 19 throughout all four, so these 16 mount holes all the way around will just plop right in there. It doesn't matter really which way you put them, but they're going to be sick. You're talking about a pretty lightweight frame with low profile. It doesn't have the camera so high up, you know, it's still pretty low pro, but when you're facing forward, you're above the props. They're going to be out of your prop line, and I mean out of your camera's view essentially, but you still have sort of that, not the total square stack mount style. Anyway, you guys, all right, on to the next part. We'll get to soldering this. Okay, back in action, back in focus. Let's just put some motors on this beast. We ain't ever sending this box back. Motor screws, no good. Too short. It's like someone got into their presents beforehand. Okay. Let's get into the action here. Waste no time. Have fresh motors to play with. Fresh HypeTrain motors. Okay, beauties. No soft mounting today. If these dampeners don't work, we may revisit the issue, but otherwise, just going straight ahead. Okay, let's just do this. Let's get it lined up straight. Start with 2. And just line it up loosely. Looking at is that 16 mils? Check that out when we go over the design. Okay. Back those both off a little, make sure that comes on straight. Sorry, you guys can't see that at all. Noob sauce. Okay. Just keep knocking these out here. Whilst remembering that my iron is getting hot over here and not to burn myself. Okay. Let's find that thread real quick. Nice. Let's find this little bad boy. I'll try and do this down here for you guys. Okay, we'll hit those a little bit. Okay. Let's get this set up. Ooh, that's bad. Bad alignment there. Back that out. Relax that up a bit. Bring them in at the same time so everyone's happy. Don't want to torque the frame by over tightening one side. Make sure it's nice and flat. Here we go. No dampeners. Alright, little beast. Spoiler alert, I don't have a scale. So I'm going to have to weigh this and tell you guys, or wait till I get a scale to do it. Okay. Let's make sure that's lined up nice. Definitely got to back that out. Let's bring this guy in. Finding that? There we go. Good. It's pretty tight. Okay. These nice open bottoms, you know, I can see clearly there that the screws are not touching the windings. So those are going to work out perfectly. Also see some gap. Maybe a little tape in there would help. We'll see. Maybe the 4 screws will do it too. Okay, let's just bring these down a little bit. To hit these with some Loctite before we go to the maiden. Or not. The maiden could be short. Okay. Frame, by the way, is a True X. I should bring up the specs and have the dual screen, but wait for that in a little bit. Okay, let's get this refuse out of the way. Okay, and there it is, completely built up, ready to fly. I've plugged it in. Just going to go over some points with you guys before I close out this video. Again, I'm going to touch on all the finer design points in an actual design video where I'm showing the programs that I use to design and all the considerations that went into this, from every detail, thicknesses, tolerances, general layout, decisions for camera, all that stuff I'll go into. But real quick, we'll go into the final points on this first prototype build. So I wanted to get into the antennas real quick. I just wanted to cover that, and that's going to lead me into a few other things. So first, I'm going to pop this open. I'm going to talk about the antenna mount here in the back, some different options for that, and that'll lead us into some other stuff. So first, I'm just going to pop the canopy. I'm actually going to pull out my camera cord really quickly because I did solder it. I did cut the wires so that there's not enough room to open the entire canopy, and that's just because it looks a little cleaner. There's less wires down there, you know, for causing less interference with whatever electronics are on there. Okay, so the camera cord is out. Also retained the ability to plug in, you know, my my OSD adjustment. I'm going to turn that off because this board, the Magnum, has Betaflight OSD on there, so we'll use that. Okay, let me get my stuff together here. I'm just going to hold this 15 mil standoff. And by the way, I want to apologize for all my terrible vocabulary throughout the video. Because it's my first video, I'm just pretty excited about generating the content, so I've skipped over a lot of just gone too fast and used the wrong vocab in some instances, so forgive me for that. First time video maker newbie mistakes. Anyway, so I'm unscrewing these guys, and I'm going to try and just maintain the screws in there so that I don't have to refit the whole thing. They're basically out. Yeah, they're out. Just want to hold this standoff. Get this guy its final release. Okay. I'm going to push that. Push the screw out of the way. And it's a tight tolerance, so it's actually tricky to do. It's tricky to do while the rubber mount's holding it, so this stuff is durable. Okay, let's just pull that out. There we go. A little further. Okay, thank you. Do the same thing on the other side. Just back that out so we can get it in easy. Okay, these rubber mounts are enduring. I'm gonna get to those later. Okay, so pop top open. You can see I've got this little bit of black tape going around the board, avoiding my bootloader button, and that's just to hold down the cable of my whip antenna and put less stress on the mount without having to use liquid tape or hot glue. So that sometimes can be pretty nice. I've used that before, it's worked. Okay, I'm just going to, you can see that this rotates also with the canopy, but this rotates all the way out, and I'm just going to pull my little whip antenna out of that notch there. Hopefully my camera stays in focus. Boom, pops up. I'm just going to push it through and try not to stress the board while I'm doing it. Okay, so there, that's out, and I'm just going to show you guys. I can come in here with a regular antenna size, and this is going to just, well, let's pull the bolts off it, the nuts. There's my vocab. And I'd thread that through, and I'd rotate that a little bit just so it's not interfering with the board right as it comes down, and I'd fold up my canopy, and that actually works. There's not a lot of stress on the board with this cord here. Set in focus, barely. Anyway, the point is, from here, once you just put your 15 mil mount screw your standoff back in, and you can put on a little button cap antenna and get some more range out of that. I decided to use the whip because it's a little bit lighter and it'll cause a little less drag in the beginning. So we'll see how that goes. I might end up switching that out. Alright, so just to show you the internals that we soldered up, You guys saw it when the top of the stack was off. Let's try and get this thing in focus here. Come on, figure it out, bad boy. Something like that. Okay, so just to show you the upper solder stuff, the XM Plus, which is some tools to point here. This is the XM Plus right here. It's soldered. It's got 3 mount pins to the board direct. The same with the VTX, which I didn't have to solder, but this was a super easy solder. Here are the camera solder points. You've got ground on the left, power on the right, and camera in right there. Oh, sorry, power in the middle, camera in on the right. And basically Betaflight OSD is going to patch that signal out to our VTX, and so we'll have some information when we're flying. Okay, so I think that's it for the internals. Just want to show you guys, get the rubberized mounts. I might have to unscrew this a little tight on the dampening there. But the FC is isolated up there. Hopefully, you know, these dampeners do a good job of reducing the vibrations that are getting to that flight controller. We don't see a lot of problems. Okay. That's pretty much it. I do have my RX wires coming down out the front, and they're sitting in tubes underneath the front legs there, just so I don't have them flying out on the sides. Something like I used to do here, just to send them out on the sides there. But so I decided to put them under the arms this time in tubes so they don't interfere with the carbon fiber, getting some interference electronically. Okay, let's just put this back together real quick. I'm going to thread my whip antenna through the larger VTX hole, and I'm going to take up the slack, and when I do, I'm going to use a hemostat to just sort of push it down into that little notch there. And come on, focus. All right, here we go. Let's just drop this top first, and I'm just sort of pulling the VTX wire through until it's tight, and I'll actually use the back edge of an X-Acto. No, I won't. No, I won't. Bad practice. I'm just kind of going inside here and pressing that VTX cable from the inside with the hemostat and with the outside from my fingers, and it's going to slip in there snugly. You could probably do that, you know, 30 or 40 times before that channel begins to open up, doesn't snug so tight, and you also have the option to do it up at the top here. But right now that's sitting just like I want it to. Out of the props, but standing up so we get good signal. Okay, so it's going to tuck the camera wires in. I'll bring the top down. I'm going to bring my standoff back, and actually, like I did before, first I'll push in the screws just to line everything up. Once they're happy, I'll put in my washer. The wires are where I want them to be, relatively speaking. I don't want those video cable wires. Oops, I messed up. They're underneath the I put them underneath the RX wires on accident, so let's just make sure that's not what the case is. Okay, looks like one of the RX wires is there anyway. Okay, that's just going to be the way it is. Details, people, details. Okay, so thread the screws back in. Do want this guy sitting low, coming out the front. May just get rid of it later. Okay, and everyone's sitting in their position happily. You can see that. And now we'll just put in our spacer and screw it in from both sides. Oh, sneaky. Alright, you will be helped. I will not leave you in the cold for now. Doing surgery. Okay. Practice makes perfect. Here we go. Let's at least get one side threaded in, and then the other will be easy. Actually, all I have to do is hold both sides, it'll thread. Just have to back that out. We already discussed this earlier, why that's bowing. That's going to be changed once everything is the proper size and the prototype is out of its prototype stage. Okay, so that's pretty easy to adjust. Perfect. Okay, now just tuck in my neurons here back into my body. Don't want any exposed neurons doing things. Might use that later, actually turn off beta flight. Okay, so now I should have also done this before I put the camera down. I'll just torque this a bit. There we go. Okay. Now, little camera wires, hemostat. Let's see, just get you in place. Love it. Be careful with your X-Acto. Don't cut your wires. Just using the back of it here to snug this up. Usually it requires doing it from both sides. Let's just rotate that back down. Let's get this guy in there. Jesus, almost cut a wire. Let's not be stupid. Sorry that's so blown out, everyone. Okay, but that's in there. Let's set that to 60. I'll tighten these little screws up before maiden flight. But hey, there it is. All built up. One of the things I want to talk to you guys about, in fact, I'm going to do this right now, is these HypeTrains have some really tight, close windings in here. Let me get this focus back up. What's up? Let's get some focus in there. You can see that on these motors, the windings at the very bottom are just sloppy enough that your screws, if they come up at all through that body, will end up touching those windings. So what we're going to do is, I've actually powered this on and it works, but I haven't got any twitches or anything, but it's just poor form. So as a point of note, the body being 5.19 or 18 millimeters right now is a little bit thinner than planned. So that's part of the prototype process. And so let me get that back in focus. Once this is 6 mils thick right here on the actual board, you know, these screws will not protrude at all from the bottom of the motors, and it should be fine. I may put some tape in there just to give it a little extra riser before the final frame comes, but anyway, it's not going to really mess it up. So just to show you guys, happy days.
Welcome to OpenTX. Flight mode, acro, engine, off.
Yeah, happy days. VTX cable is, VTX antenna is in. Don't want to power this board up without it, even though sometimes I've seen people do it and it doesn't fry anything, but you know, better safe than sorry. I don't know what's up with that delay, but we'll check that out. Anyway,
Trainer on.
sticky arming. TY Bardwell. Looking good.
Engine off.
Okay. So that pretty much finishes it for the build video. I do want to go into beta flight and show you guys the setup for this, even though other people have done it. I haven't tuned the PIDs on this. You can even feel the motors are a little warm from that, so I definitely want to get into that. But this is basically ready to go for its maiden flight. It needs a strap for the bottom, but otherwise it's good to go. And you know, minus the few adjustments, I'll take out the screws that are interfering with any of the windings. And let's see if I wanted to hit anything else. Oh yeah, the thrust column thing. my bobbled vocabulary. Let's just throw a prop on here to show you guys one of the design elements before we leave. So these arms are totally minimal, and let's get the right prop. Yay! Okay, so just to show you that, you can see where that prop and most props would be generating their most amount of thrust is just off that center line, right in the sort of the middle of that span there, and that's where the arm is the thinnest. In fact, it's almost just as thin as the wires coming around it, so it's pretty much almost a square arm. If we chamfer that, you can imagine that the aerodynamic properties of this frame are pretty good in terms of reduced drag profile. Oh yeah, I forgot to show you guys. The camera is totally protected. Gotta like that. You know, that's a gripe a lot of people have is, you know, is my camera going to be protected? And it will be here, and you will not see the frame edges. Very nice. You do not see the props if you're upper at 60. Another point, oh yeah, I forgot. The last thing, the reason why we're using the rubberized mount braces, these sort of translucent rubber pieces here, is because they have give, whereas the aluminum does not. So if this frame takes it in the face or anywhere, it's going to have a little play. And you can see, look at that, the center stack is totally isolated still. It's not receiving any of that vibration. So if this takes it really in a really hard crash, we're going to have some give. Maybe it won't break, and we'll be able to keep flying. And that's pretty exciting. So that's one of the features that we'll go talk about when we're talking about the design. There it is. Thanks for watching, everybody. Please post your comments down below. I'd love to know what everyone thinks. We'll get into the design process, the maiden flight, and everything else in future videos. Thanks for watching.